As we begin our look at factors that must match for an OSPF adjacency to form, I have for the first time ever taken a quote from a request for comment, an RFC, and this is the RFC that defined the original version of OSPF. Now there must be a reason I did this, and there is, and we're going to come back to it near the end of this video. But one thing I want to mention to you right now are these version numbers. OSPF, when you hear someone just say OSPF, they mean OSPF version 1, which is the version we're working with right now and that we're going to be configuring through most of this course. OSPF version 2 also works with IPv4, and there are some improvements to it. I'll demonstrate those to you later. And when OSPF v3 comes up, that is OSPF for IP version 6. Got it? Got it. So those are our numbers. And let's just take a look at this quote that I grabbed. The values of the network mask, hello int, and dead int fields in the received hello packet must be checked against the values configured for the receiving interface. Any mismatch causes processing to stop and the packet to be dropped. Right. Any mismatch. So we're going to see a network mask mismatch in action first, and we'll just go ahead. We're going to work with this particular network, and again, I've already configured it. I will show you the config in a moment. It's very short, and if you're unfamiliar with the command, hang in there because, like I said, we're going to be doing tons of lab work building that big OSPF network from the very beginning, but I got to have a working example to demo this for you. So right now, routers 1, 2, and 3 are on the 10.1.1.0 subnet, but notice that router 3 has a different subnet mask. It's got a /28, where the other two have a /24. Now pings are going to go through just fine, but let's see if OSPF does. And here are the commands that I have running on there right now, and they're the exact same command on each one. And what we are seeing with these commands essentially is, on each router, any interface that begins with 10.1.1, and it doesn't matter what the fourth octet is, put it in area 0. So I just need you, if you're not familiar with OSPF configs yet, I just need you to take it on faith that this is correct. So let's go to the lab equipment where I already have this up and running, and what we'll see is that on router 1, show IP OSPF neighbor, there's a neighbor ID of 10.1.1.2, so that's router 2, and this all looks good. We'll see it in more detail as we go forward, and the interface is fast Ethernet 0/0. I know you can't see the whole thing, but I like to leave the font as large as I can. Here on router 2, we see the adjacency with router 1. Noticeably absent is any adjacency with router 3, and when I run show IP OSPF neighbor on router 3, we get nothing. And that's usually not good, because when we run a show command, we're running it to see something, and if we're shown a blank line and it drops right back to the cursor, we know what that means. By this point, there is nothing to show us. So what the heck do we do in this situation? Well, if you just came in on the middle of it, it would a great command to run here to see exactly what's going on is a debug. It's debug IP OSPF hello. I love the output of this command, and we'll see why in just a moment, because since we're on a broadcast network, it's not going to take very long for messages to show up because hellos are being sent and received every 10 seconds. So, here we go, and it's easy to make an assumption that in this particular situation, somehow router 3 isn't getting hellos. But the thing is, it is getting hellos, and actually we can actually see in this line that it is sending them out. 222, 224, 005. Here's a send hello. But the thing is, this particular debug, really it's the OSPF debug to start with, because it is telling us right here and right now, mismatched hello parameters from 10.1.1.1 and mismatched hello parameters from 10.1.1.2. We are getting the hellos. That's not the issue. But the mismatched hello parameters are indeed the issue. Now I'm going to slide this over just a little bit, get that last number in, so we're working with SPF now, but of course that says OSPF. Anyway, now we just have to determine which hello parameter is mismatched, because we have a couple of them. We got hello timers, we got dead timers, and we got a network mask. And the thing is, the values, pardon me, are right in front of us. That's what I really like about this debug. We don't have to go digging for it. It's right here in front of us. Note here that we see dead R40 and then C40. And this is a comparison. The R value is the one that was received, and the C value is the one that was configured locally. So that R40, that's the one that's coming in here from router 1, and configured 40, so that matches up. Hello time, that matches up, R10, C10. The mask, however, does not match up, and that means we've got to fix that, or we're never going to get an adjacency. And we also see that's the exact same issue over here with router 2, is that the hello we're getting, the dead time matches the dead time we have locally. The hello time we're receiving and that hello matches the one local configured locally, and then the mask does not match. So actually the problem isn't in our network command. We need to change the mask on the IP address itself, and I'm just going to do that. I did a UAll that turns off all our debugs off. Let's do a conf t. We'll go to the interface. And now this mask is going to match that of R1 and R2. And do we need to do anything else at this point to make the adjacency come up? Sure doesn't look like it, because we just got a couple of messages that said loading, from loading to full. We like that. Process 1, and there are the two neighbors. And if we run show IP OSPF neighbor right here, we can see the two neighbors. This 0 is the tail end of fast Ethernet 0/0. So that's why we're seeing a 0 there. And we zip up to 1. We know what we should see, but we're just going to verify anyway, because that's the way we are. And we see two neighbors, the one with the ID of 3333, and you can see over here the address is 10113. We're going to talk about why these values are different here very shortly. We'll see it in action as well. But the key here is we now have two neighbor adjacencies where we had one, and before we wrap up, we'll run that on router 2 as well. So here is proof positive that that network mask has to match. I did pull it out of the original RFC, and that RFC is so old that, you know, you print it out, it comes out on parchment paper. But it still holds. And the reason that I brought that up is this. Especially if you're relatively new to networking, certainly nothing wrong with that. I was almost totally brand new to networking when I studied for my CCNA. And the thing is, you just have to get used to the fact that there's almost always a workaround or an exception to a rule. And if you actually do a search in Google, perhaps, on something like network mask match OSPF neighbor, and one of the first things you'll get, one of the first returns on the first page, will be something from the Cisco Learning Network where somebody posted, hey, this network mask does not have to match. And he posted why. And he was absolutely right. And you'll see other people say, hey, it doesn't have to match. It has to match 99.9% of the time. And for your CCNA exam, I would stick with the theory that the network mask has to match, because you have to get into some really specialized real-world situations where that network mask does not have to match. And I'll tell you, there's a command called IP unnumbered that you would see referred to in that Cisco Learning Network document. You have to use that. You have to get that involved. That is not a CCNA level command. And also there are some situations with VPNs where you might not have to have the mask match. But I don't want you to see those exceptions, and then what people tend to do, they say, well, you know, it doesn't have to match. Again, I tell you, 99.9% of the time it does have to match. The RFC for OSPF version 1 says it has to match, and the equipment that we just used with an up-to-date iOS says it has to match. So for your exam, I would definitely say, yes, the network mask has to match between potential neighbors, because by golly, we just saw that. Now, with that, let me step off my soapbox, but I just don't want you to get confused, because a lot of people, they see the one exception and they think it's the rule, and it's not. So what I want to do next up is take a look at these hello and dead timers. We'll review the defaults, see what the dead timer default is, and then we'll play around with that a little bit here in the lab, and that is coming up next.